All right, so the next question is an application of a quadratic inequality. So if we take a look at the direction here, it says that a town is determined that the following rule, which is right here, represents a natural disaster zone of a town map. Graph the function to determine if the home is located, the one that is located at -1, 1 is in the zone, and then explain. All right, so let's scroll down a little bit just so that we can isolate the parts that we need. All right, so we got to figure out where the vertex point is for this. Nice thing is, so this is an f of x, which means it's a y equals, so this thing's either going to open up or it's going to open down. In this case, as we look at it, since it's a positive value here, this means it's going to open upward. So we're going to have something that looks like this. And then now the first thing I want to do is just determine, okay, well, what's my vertex? What's the axis of symmetry? Just so it makes it a little bit easier for me to get this thing going. So now taking a look at the equation that we have, my vertex, which I guess here is as good a point as any to put it. The vertex is at -4, -2. All right, so that gives me a good starting point now to take a look here. So I'm going to bounce back 1, 2, 3, 4 and drop down 2. There's my vertex. All right, so there's the vertex. I've got my axis of symmetry right in there. Might as well draw in the axis of symmetry just to be a little bit more accurate with everything. So right about here. Okay, so there's my axis of symmetry. So now let's pick some points. I got to stay on one side because we know that it's going to mirror, not to mention the fact that -1, 1, the point that I'm really trying to focus on, here's the house. So I've got to see, am I going to be in the disaster zone or not in the disaster zone? So now coming over here, let's start with our points. So far we have a -4, -2. Since I don't have any fractions out here, it's safe to just use any of the values. So let's go with -3, -2, -1, 0. Don't think we'll need all those because we'll probably run out of room. But come back over to here. So if I put a -3 in here, -3 plus 4 is 1. 1 squared is just going to be 1. 1 minus 2, I'm at -1. Oops, it's -1. Writing the -1, so now I'm over here. Alright, substitute -2 in, so -2 plus 4, that's going to be 2. 2 squared is 4. 4 minus 2 is going to give me 2. So now over here at -2, I'm going to be up here. So I can see now that my house is going to be outside the curve, but that doesn't mean that it's outside of danger. So put the -1 here. -1 plus 4 is 3. 3 squared is 9. 9 minus 2, so that's going to give me 7. Let's see if I have enough room here. So when I'm at -1, 1, 2, 3, 4, 5, 6, 7. Alright, based on the fact that this is greater than or equal to, means that I'm going to have a solid line throughout when dealing with the curve. I'm just going to draw my mirror image here. Now let's draw the sketch. And now you can see from the sketch, there we are. So we've got my sketch. Now I got to determine whether or not this point is in the danger zone. So we substitute the values in. So by substituting the values in, let's see, we're at the point 1, 1. So we find out if this is true. 1 greater than or equal to -1 plus 4 squared minus 2. So 1 greater than or equal to, so now let's do the arithmetic on this side. So -1 plus 4, and if you look, actually we're going to have the value that's over here. We know this is 7. But we'll double check it just because. So this comes to 3. 3 squared is 9. 9 minus 2, then that's going to be 7. Is 1 greater than or equal to 7? No. So that means that this point is not in the shaded area. This is the shaded area. Okay, so this is actually, here's the house. Okay, so now it asks for an explanation. Okay, well, here's my explanation. The house is in the safe zone. It's not in the bad area. Okay, so what's the exact zone? Disaster zone. So the disaster zone is defined by this and all the stuff in here. Notice how the house is on the outside of the disaster zone, so therefore it's safe. All right, there's example 2. All done.